The integral of a multivariable function is really three integrals, so you have to integrate the first, second, and third. And since each one of these functions should have integration constant c, you should name them as c1, c2, and c3 because they don't have to be same numbers. But in essence, you're just solving three integration questions. Here, the questions are selected so that you can review some really basic types of integrals. So the first integral, when you have a fraction, handy formulas to use are the fact that integration of f prime over f gives you ln of absolute value of f plus c. That's very important. On the other hand, integration of 1 over 1 plus t squared, that's arctangent. So the way you tackle this is, first you split this into two integrals. And then realize that indeed this, if you differentiate the bottom, it gives you the top, right? So that does give you ln of the absolute value of the bottom, but since 1 plus t squared is always positive, you don't need to put an absolute value. You can just write 1 plus t squared. And this one, you need to factor the 3 out, so it's 3 times 1 over 1 plus t squared, whose antiderivative is the arctangent. And we're going to put plus c1 because it's the first integral. Now let's try to tackle the second one. Integration of 2t e to the t squared dt. This you need to do u equals to t squared, which means du is equal to 2t dt, so that this 2t and dt combined together will give you du. And that results in the integral being equal to integral of e to the u du, which is simply e to the u plus c2. And then you have to replace u back into, you have to turn u back into t. U is t squared, so that's what you get for the second integral. Okay. Now the third one looks very similar to the second one, except that the derivative of t is 1, it's not 2t. Here, the derivative of t squared is 2t. That's why it's so effective to be solved using the u substitution. This doesn't have that structure. So in this case, you have to do integration by parts, or something called tabular integration. So I'm going to show you the tabular integration. If you haven't seen tabular integration, please look up my videos on tabular integration. Just search for tabular integration. You should be able to find some really good lessons on it. And I advise you to learn this one because it's so much better than regular integration by parts. Now if you don't like this method and you don't want to learn it, then that's fine too. Try to integrate this using the usual integration by parts and make sure that you get the same answer as what I have. Okay. So I want to integrate e to the t while differentiating 2t, and the first column changes the signs. 2t differentiates to 2, 2 differentiates to 0. When it hits 0, you stop. E to the t integrates to e to the t, e to the t integrates to e to the t, and once you're done, you multiply like this. So it's 2t e to the t, sorry, it should be 2t e to the t, whereas this one would be negative 2t, negative 2 e to the t, and the last one, if you multiply, the last row has to be multiplied and integrated, so you're integrating 0, but integrating 0 gives you a constant. In our case, I'm going to call it as C3, and adding all these three parts together gives you the integral. So the answer to this integral is 2t e to the t minus 2e to the t plus C3. And then putting all of these back and putting them together as vectors will give you the answer. So the final answer would be ln of 1 plus t squared plus 3 arc tangent of t plus c1 times the I vector, one of the standard unit vectors that's in the x direction, plus e to the t squared plus c2 j vector, and then finally 2t e to the t minus 2e to the t plus c3 k vector.